The operations presented in this video are meant to be instructional to ensure quality construction. This video is not intended to provide a comprehensive overview of safety procedures. All parties should ensure that they are familiar with and follow all safety requirements, policies, and procedures that apply to their specific operation. Each year, approximately 100,000 disabling injuries and deaths are attributed to work-related falls. According to the National Safety Council, falls are one of the leading causes of death in the workplace. Proper use of personal fall arrest systems can eliminate or reduce injuries and deaths attributed to work-related falls. OSHA Regulation 29 CFR 1926.500 Subpart M requires fall protection when working 6 feet or more above a lower level. The only bodywear allowed for fall arrest is a full-body harness. Should a fall occur, the body harness distributes the load throughout the body, instead of concentrating the forces on the abdomen, as is the case with traditional body belts. A full-body harness should be selected based on the type of work and work environment. Customized harnesses may be required to match a worker's personal needs. Typical full-body harness components consist of D-ring, D-pad, nylon webbing, spring-loaded friction buckles, elastic keepers, stitching, subpelvic strap, chest strap, waist strap, tongue buckle, leg strap, and tagging label system. To maintain their service life and ensure performance capabilities, fall protection systems must be inspected for wear, damage, or corrosion before each use. Replace if any defective conditions exist. When inspecting the belt, begin at one end, holding the body side of the belt toward you. Grasp the belt with your hands 6 to 8 inches apart. Bend the belt in an inverted U. This helps make damaged fibers or cuts easier to see. Follow this procedure the entire length of the belt. Look for frayed edges, broken fibers, pulled stitches, cuts, or chemical damage. When inspecting the harness, begin at the top of the harness, holding the harness by the back D-ring. Grasp one strap and run your hand along the entire length. While running your hand along the strap, bend the webbing over your index finger. This helps make damaged fibers or cuts easier to see. Follow this procedure for all shoulder straps, back straps, leg straps, and chest strap. Look for frayed edges, broken fibers, pulled stitches, cuts, or chemical damage. When inspecting the D-rings, check D-rings and their metal or plastic wear pads for distortion, cracks, breaks, and rough or sharp edges. The D-ring bar should be at a 90-degree angle with the long axis of the belt and should pivot freely. When inspecting the buckles, the attachment of buckles and D-rings should be given special attention. Note any unusual wear, frayed or cut fibers, or distortion of the buckles or D-rings. Rivets should be tight and unmovable with fingers. Body side rivet base and outside rivet burr should be flat against material. Bent rivets will fail under stress. When inspecting for frayed or broken strands, the broken webbing strands appear as tufts in the webbing surface. Look for any broken, cut, or burned stitches. The tongue or billet of a belt or strap receives heavy wear from repeated buckling and unbuckling. Look for loose, distorted, or broken grommets. Belts and straps should not have additional punched holes. Buckle tongues should be free of distortion in shape and motion. They should overlap the buckle frame and move freely back and forth in their socket. The roller should turn freely on frame. Check the roller for distortion or sharp edges. When inspecting the friction and mating buckles, check the buckle for distortion. The outer bars and center bars must be straight. Pay special attention to corners and attachment points of the center bar. Look for burrs and cracks. The connecting device can be a wire rope, synthetic rope like nylon, or web lanyard, rope grab, or retractable lifeline. However, Energy-absorbing capable devices are recommended because they significantly reduce the forces generated in a fall. An energy-absorbing lanyard is the typical connecting device used by PennDOT. Connecting devices should be attached directly to the D-ring located on the back of the harness, the dorsal D-ring, which should be positioned in the middle of the wearer's back. Typical energy-absorbing lanyard components consist of energy-absorbing web lanyard, double-locking clip, double-locking rebar hook, warning flag, stitching, and label. When inspecting an energy-absorbing lanyard, bend the webbing over a pipe to reveal any cuts or breaks. Check both sides. Look for swelling, discoloration, cracks, charring, or breaks in the stitching. Check the warning flag. If it has been activated, remove the lanyard from service. When inspecting the hardware snaps, inspect the hook and eye for distortions, cracks, corrosion, or pitted surfaces. The latch should seat into the nose without binding and should not be distorted or obstructed. The latch spring should exert sufficient force to firmly close the latch. Latch locks must prevent the latch from opening when the latch lock is not depressed. PennDOT utilizes various makes and models of full-body harnesses. To ensure proper donning of the harness, please review the manufacturer's donning procedures. The donning procedures can be found on the manufacturer's websites, shown here. The anchor point must be capable of supporting 5,000 pounds per worker. Examples of acceptable anchor points include, but are not limited to, eye bolts, support beams, cross-arm straps, beam trolleys, etc. Ask yourself this question. If I wouldn't suspend a pickup truck to this anchor point, why would I be willing to risk life by tying off to it? Also, if you are still unsure, find a qualified person to approve the tie-off point.